All right, so today now you're going to also learn about isosceles and equilateral triangles. You're going to utilize the properties of isosceles triangles and equilateral triangles and use them to help you, say, realize some other stuff. What is that stuff? I don't remember. Let's find out. Anyways. All right, so let's look at an isosceles triangle first, shall we? We shall. Excuse me, good grief. All right, so we know in an isosceles triangle two sides are congruent, right? And so those two sides that are congruent are called your legs. Now, the side that is not congruent on an isosceles triangle is called a base. Now, boy, I'm going to say now a lot. Anyways, and because of that, we can also assume that, say, angles that are opposite those sides, in other words, like this angle right here, and say this angle over here, that are opposite those sides, those are congruent. Okay? Those two angles are called your base angles, and the angle that is not the one that's congruent, the different angle, is called a vertex angle. Notice that the vertex angle is opposite the base. Okay? So again, those two angles are called, the congruent angles are called base angles, and the one that's not congruent is called a vertex angle. The congruent sides are called legs, and the base is the non-congruent side. Now it doesn't matter how that's situated, okay? Because look, like here I've got this done like this, and I got this another type of triangle. The legs again are the ones that are congruent, and the base is that other one that's going slanted. The vertex angle would be the one between the two legs as part of the included angle of the two legs. You could say it like that. And the two congruent sides would have been the base angles. All right. So using that idea, we have Theorem 410 and 411, isosceles triangle theorem. Two sides of a triangle are congruent, then the angles opposite those sides are congruent. So they're reinforcing that. Converse of an isosceles triangle, if two triangles are congruent, then the sides opposite are congruent. Which you already knew, but we got to just let you know. All right, equilateral triangles, we get some corollaries here, which are kind of like postulates. A triangle is equilateral if and only if it is equal angular. Each angle of an equilateral measures 60 degrees. Okay, so basically if we know the angles all measure 60 degrees, then we know they're equal angular, which means then we know it's equilateral, which means all the sides are the same. Go with that. Okay, so this is horrible drawing. Just go with it. All right, just please go with this. This is like, yeah, this is why I don't draw very often. Anyways, all right. So here we have an isosceles triangle. They want you to find the missing sides. Now, pay attention here. Notice which two sides I've included. So, by doing this, I'm saying that angle A, we obviously can see angle A and angle B are congruent. That means then this side and this side are congruent. So AC and BC are congruent, which then allows me, based on Theorem 4.11, which then allows me to also say that makes all three sides congruent. Therefore, this is an equilateral triangle. And if it's an equilateral triangle, then I can set the 4y minus 5 equal to each other, plus I know that the angles are 60 degrees. So if I'm saying this is equilateral, I can now say 2x is equal to 60, and solve for x by dividing by 2 to get 30. And I can say 4y minus 5 is equal to 3, add 5, and then divide by 4 to get 2. And there you go. A lot of this would do stuff like that. So if I ask you to find like a missing value or prove something is congruent, you should be able to do that. And I think we should try to go over some more examples here so y'all can kind of see that. But otherwise, that's really about it. And we are done for today. And I will see, hopefully you will have these notes. All right, thank you so much for your time. Y'all take care.